Hello friends, welcome to GT Science tutorial. In this video, we are going to understand about the different solutions in colligative properties. We know that solutions are the homogeneous mixture and there are different ways to classify a solution. And in colligative properties, there are three types of solutions that we need to know about. They are isotonic solutions, hypertonic solutions and hypotonic solutions. So in this video, we are going to understand about all three of them one by one. So let's start. A solution can be classified into isotonic, hypertonic and hypotonic solutions on the basis of osmosis phenomenon. So let me explain it to you. Suppose we have a bucket over here. I think beaker. This is the beaker and in which there is this solution. We are not taking distilled water in this case, okay? This is the solution. There is salt in it as well, but the concentration of salt might vary in each cases. And suppose we put red blood cell in it. This is the red blood cell. Okay, this is the salt solution, and this is the red blood cell, right? Then what will happen? Red blood cell has a semi-permeable membrane around it. Then obviously there will be osmosis phenomenon over there. But what kind of solution is called isotonic, hypertonic and hypotonic? That's the main question, right? So we need to know the concentration of salt or concentration of the solute inside the RBC. Well, the concentration of RBC actually is equal to 0.95%. Okay, this is the concentration of any solute inside the RBC. And similarly, if we take different concentration of liquid around it, then obviously either water will get in or water will get out. We have to see that condition over here. Let us consider we are taking a salt solution of 0.95%. Suppose there is 0.95% salt over here and rest of the material is water in this solution. Then what will happen? Will there be any osmosis phenomenon? That's the question. Well, osmosis phenomenon is the phenomenon in which the solvent molecules travel through the semi-permeable membrane through the low concentrated solution to high concentrated solution. Now you can see over here as the concentration of both the thing, that is RBC and this liquid, is equal, then there won't be any flow of solvent molecules from outside or from inside, right? There won't be anything, and the size of this RBC will not change. It will be just like that and it will not change. This type of solution, we are talking about this solution, okay, outside solution. This type of solution is called isotonic solution. Isotonic solution. So we can say that if the concentration of the solution and the concentration of the solution inside the material is equal, then the solution outside is called isotonic solution. Let me write the definition over here, okay? If the concentration of solute in the solution is equal to the concentration of test solution. Let's call it test solution. Then the solution is called isotonic solution. I've written to then. Okay, so this solution is called isotonic solution. The reason for that is the concentration of this outside solution is equal to the inside concentration of the RBC, and we need to know that the solution is classified as isotonic, hypertonic and hypotonic solution only in relative cases. Okay, what type of material is kept in it, what type of matter is over there, it depends on that. This is not a property of solution, but this is the relative property. Okay, we are trying to understand this in relative condition. So look at here, this type of solution is called isotonic solution. Example 0.95% of sodium chloride solution is isotonic with red blood cell, that is RBC. So this is an example for that. 0.95% of NaCl solution is actually isotonic with the red blood cell. I hope you understood about the red blood cell, and in this case there won't be any flow of solvent molecules around each other. As a result of that, the size of this RBC will not change. It will neither decrease nor increase. Now let me erase this portion to understand another case. Okay. So we understood about the isotonic solution. Isotonic solution are those solutions whose concentration is equal to the test solution's concentration, right? Now let's understand about the hypertonic solution. Hypertonic, that means higher, right? Hyper means higher. We say that I am hyper, he is hyper, that means they are angry, right? So hyper means higher concentration. So the concentration of this solution will be higher than the concentration of the test solution, that is the solution inside it. If we consider RBC in this case as well, then its concentration is 0.95%, right? And if we take a solution of 2% NaCl, this is NaCl solution, then what will happen? As we can see over here, there is 2% of NaCl in this solution and only 0.95% of the solute in the test solution, that is inside the RBC. Then what will happen? Obviously, due to osmosis, water molecules from inside will start to go outside, because we know that water molecules flow from low concentration region to high concentration region. There is only 0.95% of solute, so this is highly dilute and this is less dilute. So obviously the water molecules will come out, and in this particular case, this solution, the given solution, that is the 2% NaCl solution, will behave as the hypertonic solution because it has higher concentration than the test solution. Let me write the definition of it. The hypertonic solution is defined as the solutions whose concentration is more than the test solution. Concentration is more than the test solution. So the concentration of this solution will obviously be more than the test solution. And in this case, water molecules will come out of RBC and it gets shrinked. This is also called shrinkage. And in examination, you can also write low osmotic pressure in place of low concentration. Okay, so this is the case, and this phenomenon is also called exosmosis. So in examination, it might either ask, what do you mean by hypertonic solution or exosmosis solution? So you need to be able to say this: if the concentration of the solution is more than the concentration of the test solution, then water molecules will come out of the test solution, that is this RBC, due to osmosis phenomenon, and as a result of that, this will shrink. This solution, this outside solution, is called hypertonic solution. Okay, so I have understood about the hypertonic solution. Now it's time to understand about the hypotonic solution. For that, let me read this portion. For hypotonic solution, let us consider the concentration of this solution, this outside solution, is 0.3%, that is less than the concentration inside the test solution. Then what will happen? Obviously there will be less amount of solute over here in that solution, and there will be more amount of solute in the test solution, and due to osmosis, water molecules will start to get in from all directions through the semi-permeable membrane, and as a result of that, the size of this RBC will increase. That means it will swell, right? Now in this case, this outside solution is called the hypotonic solution. Hypo means less concentrated solution than the test solution are called hypotonic solution. Let me write the definition of it. The solutions having lesser concentration, or you can also write less osmotic pressure than the test solution, it are called hypotonic solutions. In this case, water molecules will diffuse into the cell, that is RBC, and RBC swells. That means its size increases. This type of solution, outside solution, are called the hypotonic solution, whose concentration is less than this test solution's concentration. This phenomenon is also called endosmosis. So see, the words are very much relative to each other, right? Endosmosis, that means the water molecules are going inside. Exosmosis, the water molecules will coming outside. So I hope you understood about the isotonic, hypertonic and hypotonic solution. These solutions are classified on the basis of osmosis phenomenon, that is the concentration solution. The concentration of the solutions are as relative to the concentration of the test solution. We are considering this RBC solution to be the test solution. We can also consider an egg in place of it, or a grape in place of it. So you can consider any solution to be the test solution. We just have to compare the concentration of the test solution and the outside solution. If the concentrations are equal, the outside solution is called the isotonic solution, and in that case, that is called isoosmosis as well. And hypertonic solutions are those solutions whose concentration is more than the test solution, and hypotonic solution are those solutions whose concentration is less than the test solution. So we are classifying isotonic, hypertonic and hypotonic solution in relative. Okay, we have to relate it with other concentrated solution. We are comparing it, or comparative study, you can say that as well. So that's all in this video. I have understood everything about isotonic, hypotonic and hypotonic solutions. If you like my video, please share this video as much as you can, and thank you for watching the video.